All right, so today's lesson is called, this is 1-6, but it's called Polynomial Functions and End Behavior. This is actually something that they take from Algebra 2 Honors, which is the end behavior, what happens at the beginning and the end of your graph. But then it converts it into something that's called limit notation. This is going to be your first exposure to limit notation, and it is something that we will use literally sporadically throughout all the units. So it's really important we understand it. Don't freak out if it looks weird today. Okay, but it will be something that's definitely used several times. So first of all, we go back to our skills of end behavior. End behavior means what's happening at the ends of your graph, on the left and on the right. If it is an odd degree polynomial, okay, which means the highest exponent, because that's what the degree is odd, then it has opposite behavior at the end. One arrow is pointing up and one arrow is pointing down. If it's odd and a, which is the leading coefficient, is positive, then the graph falls left and rises right. So my arrows point down on the left and up on the right, just like a cubic function would do. If a is negative, then the graph rises to the left and falls to the right, so it's the opposite behavior. Like as if your x cubed was negative. Now, if it's even, your highest exponent is even, then they have the same behavior. So if it's even, both point up or both point down. If it's even and positive, both ends point up. And if it's even and negative, both ends point down. So the ends of your graph are going to both point up or both point down. If you forget, you can fall back on your parent functions of your x squared, which would be your parabola, and your x cubed, which would be your cubic function. Those things follow these rules. So if it was a parabola that was positive, then they would both point up. If it's parabola that's negative, they would both point down. If it's a cubic function that's positive, it would rise right, fall left. And if it was a cubic function that was negative, it would rise left and fall right. So if by chance you forget, you can always fall back on those parent functions. Now, they won't always look like this. They're going to have rises and falls in between. All we know is what's happening at the ends, okay? So we will eventually learn, kind of like what we did with the where it was greater than or equal to 0. You'll combine your end behavior with your zeros, your multiplicity, and you'll be able to determine what your graph kind of looks like. Not exact, unless you plot a whole bunch of points, but at least an overall shape of it. Now, what we're going to do is write that notation in something called limit notation. So instead of saying both point up, we have to write limit notation. Instead of saying both point down, we write limit notation. And this is what limit notation looks like, okay? Now, this is not the limit of the graph. That means something different. We're using limit notation to find the end behavior, okay? And the way this works is, okay, if it's even and positive, then both my arrows point up, right? So as x approaches infinity, that's what that little arrow means, infinity. So as x is going to positive infinity, that means, let's just say I had a parabola. As x is going to positive infinity, my x values are getting bigger. My y values are also going to infinity because my y values are getting bigger, okay? So that's that notation on the left. As x approaches infinity, y approaches infinity. Now, in limit notation, it looks like this. It's this one. This one goes with this one. As x approaches infinity, goes under LIM. So we write LIM. The x goes underneath the arrow with which direction we're going. So if it's x arrow infinity, we're saying as x approaches infinity, meaning the right side of my graph. P of x or f of x or g of x or k of x, whatever the function's name is doing what? And that's what your y is doing, because the f of x, g of x, p of x, whatever is the same thing as your y values. So because this arrow is going up, I would say that the limit as x approaches infinity is p of x equals infinity. And then as it goes to negative infinity, so if I'm going in this direction, negative infinity would be left. As my x is going left, what's happening to my y values? They are also going up, which means they're going to positive infinity. So the limit as x approaches negative infinity, p of x also equals infinity. So these should have the same behavior if these are even. They are either both going to positive infinity or they are both going to negative infinity like the one underneath. So in this case, if it's a parabola, let's just say, as my x values go to negative infinity, my y values go to negative infinity as well. And as my x values go to positive infinity, my y values go to negative infinity. So this goes here, and this, I know it's confusing, goes here. Because this guy should match what's underneath the LIM. This goes here. So if it's pointing up, it's going to positive infinity. If it's pointing down, it's going to negative infinity. Okay, now if it's odd, they're going to have different signs. One's going to go to positive infinity. One's going to go to negative infinity. If your x is going to positive infinity, this means my x is getting bigger, and it's an positive odd function. That means it rises right and falls left. So as I go to positive infinity, my y also goes to positive infinity, which is this one. And as my x goes to negative infinity, my y goes down, which means my y goes to negative infinity. Those two match. And if it's odd and negative, now it rises left and falls right. As my x goes to positive infinity, my y is pointing down, so my y is going to negative infinity. And as my x goes to negative infinity, my y goes to positive infinity. Yes.
So is it only based on the y?
Well, the direction it's going is based on the exponent and the leading coefficient, but what you're saying is happening is based on the y values. So as the x values are doing this, what are my y values doing? Yep.
Do you need to put that thing on the bottom of limit?
Yep. So this would be how you answer these questions now. LIM over, and if you're doing end behavior, you're going to have one that goes to x to arrow negative infinity and one that goes x arrow positive infinity. X arrow negative infinity is saying the left side of your graph. X arrow positive infinity is saying the right side of your graph. And then you have to figure out, and then you have to do the corresponding y. So if we're talking about end behavior, it can only be one of these four options. That's it. They're either both going up, they're both going down. One's left's going up, right's going down, or left's going down, right's going up. It's it. Those are the four options, okay? You just got to be able to take the words and put it into limit notation. All right, so this one says describe the end behavior of the graph of the polynomial function. We're going to do it both like simple, and then we're going to do it in limit notation. Okay, so first off, you got to make sure it's in decreasing degree order because it may not always be. So don't let it fool you that the first thing it throws at you is the highest exponent. That might not necessarily happen. So if I look at A, I'm looking for the highest exponent. The highest exponent is what? 3, which makes it odd, which means one's going up, one's going down. Then I look at the front of that same term. The leading coefficient is negative. So in like regular words, what's happening here? Rises left and falls right. Now left is the limit as x approaches negative infinity. And right is the limit as x approaches positive infinity. Right? X negative infinity is pointing left. X positive infinity is pointing right. Then next to it is what we say the y is doing. So f of x in both of these spots. F of x. And what's happening as x approaches negative infinity or goes left? What's happening to the y? No, as it goes left, it does what? It rises, which means my y is getting bigger, which means f of x is approaching positive infinity. And on the right, as x is approaching positive infinity, so I'm pointing to the right, what's happening to my y values? They're falling, and falling means it's pointing towards negative infinity. So rises, positive infinity, it's getting bigger. Falls, negative infinity, it's getting smaller. Okay, go to B, highest exponent. 4. What's true about the arrows if it's even? They're the same. Both up or both down. Now I go negative. 3 on the front. So what's happening? Falls left and right. They both point down. So my limit as x approaches negative infinity and my limit as x approaches positive infinity, f of x would equal what for both?
Positive infinity?
Nope, it's falling.
Oh, negative.
Negative infinity. Down, negative infinity. Up, positive infinity. Go to the next one. Highest exponent. 3, not the first one, right? What's true about the leading coefficient? Positive. So it's odd positive. So what's falling, what's rising? Falls left, rises right. So my limit as x approaches negative infinity and my limit as x approaches positive infinity. If it's falling, what's my f of x doing? Going to negative infinity. And if it's rising, my f of x is going to positive infinity. You try that last one. All right, so what's your highest exponent? For the leading coefficient is positive or negative? Positive. So what's happening to both my arrows? Rises. Both rises, left and right. So as x approaches negative infinity and x approaches positive infinity, what's happening to the graph? It's going to positive infinity. So it could ask you to describe the end behavior using limit notation. It's looking for both sides. It could ask you just one. It could say what's happening as, and it would say limit as x approaches infinity or limit as x approaches negative infinity, and then you would just fill in that one side. Questions? All right, so this one says, sketch the graph of the polynomial function that could match the statement. Now, we know nothing about the in-betweens. All we know is the end behavior. So we're literally just drawing the ends of the arrows, okay? If I look at A, this says as x approaches negative infinity, my graph is going to negative infinity, so it's going to decrease. So this side of my graph goes down. Then it says as x approaches positive infinity, my graph does what? Goes down. So it goes like this. You'll see little like dot, 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 dot. Whatever happens in between, we have no idea what it is. All we know is the ends. So if this was multiple choice and you had 4 choices, one of the one that points both arrows down would be the one that could be your graph. And it will say that. It'll say could match because it doesn't have to. All right, B. What's happening as x approaches negative infinity? It's falling. And as it's approaching positive infinity? It's rising. So again, we have no idea what's happening in between here. All we know is the ends of the graph. Still good? All right, let's go through the homework. That's it. Like this lesson's super easy, hopefully. Okay. Questions on the PDF. So let's start with, like number 1, it was less than or equal to 0 this time. So it was from negative infinity to 1, and then 7 to positive infinity, brackets on both. Number 2, it had multiplicity this time, so you had to be careful. It bounced at the 2, crossed through at the 0, at the 4, and at the negative 8. Well, so now put it together with the lesson we just did, and this lesson should get easier. At this point, we had only talked about if it was an x squared, like if it was even, they both went up or they both went down, right? So odd's the other way around. But now put it together with what we just talked about. If you take, which I think is interesting that your units go in that order. But if this is x to the first, right, that one's x to the first. This, I don't have to expand to know that it's going to be x times x times x times x, which is x to the fourth. This is going to be x to the third, and this is going to be x to the first again, right? So if I multiply those things out, I would add the exponents. 1 plus 4 is 5, plus 3 is 8, plus 1 is 9. So my leading term would be x to the 9th, and it's positive because all of those x's are positive. Then, now think about what you know now. Odd, positive, points, down left, up right. So I would start with that. Literally plot your zeros, which were -8, 0, 2, and 4. It crossed through everywhere except for -2, at 2 it bounces. And that's because you had an even amount of 2s, right? So it would fall left, it would rise right, it would cross through, bounce off, and have to come back up again. So now I know what's above my x-axis, and now I know what's below.
And we can't use the calculator.
Correct. You wouldn't have a calculator in that question. All right, 3. So 3 and 4 were pretty similar. Again, you had to figure out what the arrows were doing on the ends. And again, hopefully we have a better understanding of that even now. And then your multiplicity of your zeros to tell you where it crossed through and bounced. Same with 4. You had to factor it, find your zeros, and then the arrows. Questions on those? Okay, then this one is just saying find for each polynomial, the degree is listed along with the real zeros. Find the number of non-real zeros. So remember that non-real plus real have to add up to the degree. So if there are 2 real ones for 5, that means there's 2 non-real ones. For 6, there are 6 non-real ones. And for 7, there are 0 non-reals. So there's 5 total, right? Degree is 5. It says x is 3, x is 8, and x of 3 has a multiplicity of 4. So if it's 3 and 8 as my zeros, and 3 has 4 of them, then there's 5 total real ones. Yep.
Can you imagine formula that?
These are all test questions, guys. Like, these are all fair game. So 6 says 13 total, right? And you've got -9, 0, and 13. And then it says 0 has a multiplicity of 5. So 0 has 5 of them. So 5, 6, 7. 13 minus 7 is 6. And remember, if it's non-real, it has to be what? What kind of number? It is imaginary, but how many?
You need a pair.
You have to have an even amount because they come in pairs. So if there's multiple choice question and one says 5, rule it out. It can't happen, okay? You can't have an odd amount of imaginary numbers. They come in pairs. All right. 8 and 9 were just your, like if I give you one real non-real zero, what's the other one? 10, you're trying to find the degree of the polynomial. So we're figuring out how many differences it takes in order for it to be the same. This first one was first difference. It didn't happen. Second difference didn't happen. Took to the third difference for these to be the same. So the degree is 3. And then 11, it took to the fourth difference for them to be the same.
We don't need to say whether it's quadratic or not.
No, so that will eventually be how you classify it. It's actually usually built into like an FRQ. To classify the type of model, whatever, and it will say like linear, quadratic, cubic, whatever, and you choose it from there. This asks for the degree, so it's just the number. Yep. Then it asks for even or odd, or neither. Remember, even is symmetric to the y-axis, like number 3. Odd, whatever happens in the top left gets flipped down to the bottom right, like 1, and neither would be 2. For the checks for algebraically, we plug in a negative x. If it goes back to the original, then it's even, like number 5. If each term changes sign, then it's odd, like number 4. And if it's neither, it's neither. So if there's a mix of even and odd, or constants and even or odd, then it's going to be neither. Well, it's not going to be odd. An even and a constant can be even. All right, AP Classroom. So number 1, it said, which of the following could be the graph? So again, you've got it's already factored for you. You have an x that is 0. You have an x that is -1 with a multiplicity of 2. And then you have another value there that you don't know. So we've got 3 zeros. Did I cut off? Yeah. You've got 3 zeros, but it doesn't say what that third 0 is, which means it could be a repeat 0, okay? Or it could be something different, right? Where a is a real number. Yeah. So I know it bounces off of the of the -1. That was one indication, which is not here, not here. This one also bounced, okay? It could have crossed through the 0 or bounced off the 0, but both arrows had to point up because you have an x squared, and an x, so it's an x to the 4th. So it could have, like 0, A could have equaled 0, in which you would have had something that bounced at 0. Or A could have equaled any other number, which would have crossed through. But if it crosses through, it gives you arrows in the opposite direction, which means D is the only answer. That works here. All right, 2, you were looking for the common difference. It took to the 4th degree, or 4th difference. 3, it said which of them could define P. You've got a 0 at -3 with an odd multiplicity, and you've got a 0 at 4 with an even multiplicity. So as you go through, the x minus 4 had to have an even multiplicity, which rules out C and A. And then you're left with x plus 3 or x minus 3. And if the 0 is x minus 3, then my equation has to be x plus 3.
Can you go back to question 2?
All right, number 4 said the function q is polynomial degree 3 if q of 5 equals 0, which of the following must be true? Well, if it's 5, 0, that means your y is 0, which means that it's a 0 along your line. So that doesn't necessarily mean that the -5 also has a 0. If it says that this is just one of your zeros, it doesn't say those are the only zeros. So your other 2 zeros could also be real numbers. They just didn't give it to you, which rules out B. C says it can be expressed as x minus 5 times p of x, where p of x has a polynomial degree 2. Well, this would be x to the 1st, and if this is x squared, that produces an x to the 3rd, so that could work. And then the second one says that p of x over x minus 5, where p of x is a polynomial of degree 4. It said, so then it would be x to the 4th, something x to the 4th, over x minus 5. So the problem here is that this could reduce, but it doesn't have to. So it could reduce it down, but it doesn't mean that, well, this doesn't work because this would be undefined. Where x equals 0. No, where x equals 5. But you have a 0 at 5. So that's the problem with that one. So your graph would literally be undefined at 5 because you have a domain restriction, which would mean that you couldn't have a 0 at that. So I would say this, not a test question yet. Could eventually be. Yeah, especially we're going to get into rational expressions next time. We'll understand that a little bit better. But up until this point, could be fair game. 5 says the leading term of the polynomial function where a, n is a real number and n is a positive integer. The factors of p include x minus 3, x minus I, and x minus 2 plus I. What's the least possible value of n? Well, if you have x minus I, that means you also have x plus I. If you have x minus 2 plus I, you also have x plus 2 plus I. So now you have 5 roots, okay? You might have more, but it says what's the least, which would be 5. All right, 6 says a polynomial function has the form ax to the j plus bx to the k, where a and b are non-zero constants and j and k are non-negative integers. Which of the following guarantees p is an even function? In order for it to be even, if k is 0, that means there's no variable there, okay? But that means that j could still be even or, positive, even or odd, which means that doesn't work. A doesn't work. If j equals 2 times k and k is even, well, think about the possibility there. If k is an even number and I double it, what happens? No matter what my even number is that starts, if I multiply times 2, what's happening? It's staying even, right? So now I have both exponents that are even. If both exponents are even, this is going to be an even function, right? So that's that one. If it said j plus k is even, well, I could have x to the 1st plus x to the 3rd. Add them, that's an even number, but they are both odd. So that doesn't work. J times k is even. I could have x to the 1st times or plus x to the 4th. My product is even, but I have an odd exponent, okay? So that one doesn't work either. So try numbers out if the expression is confusing, then try some numbers out and see what would work there. That's the only one that works. Any questions overall?